Okay, so let's do B and C. So that could even fit another small one on here if I wanted to. So B and C, F is the same function, except the codomain is different. Yeah. So the domain's the same, the rule is the same, but the codomain is different. And the fact that the codomain is different makes this surjective, but this not surjective. They're both injective though, right? So, and the proof is the same for injective. So proof that F is injective is you want to assume, or pick two different x values and assume that their y values are the same. And if their y values are the same, then just plug it into the function. You get F 5a equals 5b, and divide both sides by 5, a equals b, right? Because, yeah, the only way you're gonna, basically, if you're saying that I've got two integers such that when you multiply them by 5, you get the same number, doesn't take a rocket scientist to figure out that they're not different numbers. When you multiply something by 5, and you get an output, and somebody else multiplies something by 5, they get the same output. They better have multiplied the same thing by 5. Okay. And that's basically what that's saying. Okay. And then the same thing here. So here it could have been like anything that we picked out of Z, but we said it was an output, so it had to have been a multiple of 5. Here, when I write 5Z, that's really the set of all integers, but then multiplied by 5. So this only consists of like 0, 5, 10, 15, 20, and then all their negatives and stuff. This is all of the integers. But still, they're multiple, so these are only multiples of 5 that you pick out of there. So same injective proof, right? And then, we could, like, you may be worried, well here, like, what if A was 3, right? Well, that's okay because 3 is an integer, and that's okay because 3 is an integer. Right? So 3 gets sent to 15. So anyway, here F is not surjective, here it is, okay? So the fact that it's surjective is because everything over here in the target space is automatically a multiple of 5. It's the set of all integers multiplied by 5. So all you got to do is pull the 5 off there to figure out what got sent to it. Okay. So basically, as long as you pick something in 5Z, it's a multiple of 5. So multiple of 5 means 5 times something. Take that something. That's the one that got sent there. Here, though, not all integers are multiples of 5. Like 4, for example. 4 is not a multiple of 5. So there won't be something that gets sent to 4. Right? Because if it were, and if f of a is 4, well then that means that, basically 5, because f of a is plug in a, right? So that's going to be 5a equals 4, and there's no integer a. There's a rational number a, namely 4/5, but 4/5 isn't an integer, so you won't have any